Alrighty, let's see what we got today. Ways to express an integer as sums of powers. Given two integers n and x, return the number of ways n can be expressed as the sum of the xth power of unique positive integers. In other words, the number of sets of unique integers n sub 1 to n sub k, where n is equal to the sum of n1 to the power of x and 2 to the power of x all the way to nk to the power of x. Since the result can be very large, return modulo 10 to the 9th plus 7. For example, if n is 160 and x is 3, one way to express n is equal to 2 to the third plus 3 to the third plus 5 to the third, 8, 27, 125. Okay. If n is 10, x is 2, there's one way, and that's 3 squared plus 1 squared equals 10. And that's the only way. I guess 0 could possibly be a return value. N is 4, x is 1 squared. No, sorry, this is to the first power. So it'd be like 1 to the first plus 3 to the first. You can't have 2 to the first because then you'd have a non-unique. It'd be 2 to the first plus 2 to the first, which is not possible. You can also have 4 to the first. Okay. Alright, so let's go ahead and create the mod value. Huh. So the biggest it could be would be like whatever base to some power is bigger than the value. I think I'm going to start by creating like all the possible exponential values that could be part of the set. So let's go, I'll call them terms, and so the possible terms is like 1 to the power of x, and then 2 to the power of x, all the way up to something to the power of x where that thing is too big. So I'll start with while, should be while. I'll start with value as 1. Is that right? 1. You're increasing the base each time, so it's not like you're multiplying by the x value each time. So I think it's actually, I guess base equals 1, while base to the power of x is less than or equal to n. How should I do this? I don't want to calculate it twice. I'll start with, I guess it's always going to be 1, huh? So I'll say base is 1 and value is 1. Let's say while value is less than or equal to n, and the value is the value of the exponential term. So while value is less than n, terms dot append this value, and then the base increments by 1, and the next value is equal to base to the power x. I'll go ahead and just print out terms here. I think this is probably the fastest I can do this, creating this array. Alright, 149 squares, and then powers of to the first power is 1, 2, 3, 4. Okay, that's right. Okay, so the number of ways I can seems like it might be recursion or maybe dynamic programming. The number of ways I can sum up to n using this array of terms would be the number of ways I can sum up to like n minus a term if I go down one index within the array. So for instance, I can sum up to 4 using starting at index 0, or I can say I can sum up to 3 having used index 0, subtract 1 from it, so 3 starting at index 1. Or if I didn't use 1, I can say I can sum up to 4 starting at index 1. So there's like a bit of recursion there. I think that might be too long though. That might be too long. I think like maybe too, well, recursion of functions is going to be too long. I think it's going to be like binary exponential pathing. So there's like 6 off, like 2 to the 4th kind of 2 to the 4th different paths. We can maybe use a stack for it instead, using recursion with a stack. I mean, I guess. Okay, how big is this? N can go up to 100 or 300, but the power can only go up to 1.5. So if n was a number that was like, if the power was 1 and n was 300, which is actually kind of the worst case, I think, because there's the most possible branching. The stack would be like almost, maybe I need to do this backwards actually. Go ahead and reverse the terms. Reversing the terms would help because it's more of a limiter if you were to add or remove a big value to the space of possibilities. I could be wrong about that. But it seems like there'd just be more branching opportunities if we had a n that just incrementally changes when you have small values that you're changing at the start. Number of ways you can get to n using all of the array, and then you reduce it. Number of ways you get to n minus some value up to some point in the array. Recursion. Recursion just doesn't seem like it might seem like it'd be too long. 10, 2. So it has to be 1, 4, or 9. So, and it has to sum. So you'd say, okay, so it's 10, your array is 1, 4, 9. You start by having 10, 0, which is Your goal is 10, your index is 0, and then you go like 10, 1 if you don't subtract the 1 from the 10, or you go 9, 1. And then if you go 10, 1, then you can go something like 10, 2 if you don't include the 4. Or if you do include the 4, then you go 6, 2. By including in, like, as part of the sum that you're subtracting. And then 9, 1, you can go 9, 2, or you can go subtract the 4, so 5, 2. I guess at any point if your goal value is smaller than the next value, then that's just no bueno. Your goal value matches, then obviously it works. And this is using the sorted version. I do the reverse sort, 9, 4, 1. So 10, 0 goes to 10, 1 if you skip the 9, or goes 1, 1 if you don't skip the 9. And then for 10, 1, obviously you have to skip any numbers that are, this one can go, actually, yeah, it can go 10, 2, or if you subtract the 4, it will go 6, 2. Both of those just don't work anymore. And then 1, 1, you skip the 4, you go 1, 2, and then that works. Is that fast enough? Is that fast enough? Could I implement this with non-recursive function? Just a stack, maybe? Well, I do a stack, right? Why couldn't I do a stack here? How would I handle big values here? When would I encounter really big value? If I did a stack. So when I see the end result, is that when I pop the stack? 10, 1. I guess when I pop the stack, what does that mean? When I see results, so 10, 1 becomes 10, 2, 6, 2. I think it. I think what I'm doing here is. I think what I'm doing here is what am I doing actually? for every value that's possible. So I start with n, and I keep a count of where n is the goal value, and I start with the goal value, which is initially n, and an index, which is initially 0, and then I create a set of next goal values. Yeah, I think so. I create a set of next goal values that either for every goal value up to that index, it's going to keep that goal value, keep that goal value and subtract the value at the index, or keep the goal value and don't subtract the value at the index. And then have to have some stuff. Each goal value has to have a count, I think. Each goal value has to have a count. And I kind of merge them. Okay. So what I'm thinking of is initially the goal value is n, and the number of ways of getting that so far is 1. But in theory, if I had let's say I had 2 goal values at a certain index, let's say goal values were like 20 and 30, and the value at the index is like 8, 20 and 30. So the number of ways I get to 20, I would keep that number of ways and subtract 8 possibly. So I have like 20 and 12. And let's say there were like 5 ways of getting 20. So it'd be 5 ways of getting 20 and 5 ways of getting 12 on the next round. And then similarly, if I have 30, and there's 10 ways of getting 30, then I have 10 ways of getting 30 on the next round, or 10 ways of getting 30 on, or 22 in the next round if I subtract 8. Okay, so I guess that's going to be like for each round there's going to be like, I think probably a dictionary of goal values and the ways of getting it, maybe. I guess round is a name of function. Let's say I have a goals dictionary. And the goal is initially n, and the ways of getting it is 1. I'll have an answer. Okay, so for every let's say value in the goals, or how do I iterate over dictionaries like t and value? Goal and count in iterate over values of or key value pairs in dictionary Python. What is the syntax here? Items, key value in goals to items. I also need to have an index, don't I? yeah, this needs to go index first for every index in the length of terms, in the range of length of terms. So this index will have some term value. I guess I can just iterate over the terms, maybe. I'll just use this for now. So I either will subtract or not subtract. So what's going on here? So if the goal is bigger than the term, then it's no bueno. Or the goal is smaller than term, then it's no bueno. If goal is less than, or yeah, if I have like a goal of 5 and the term is like 100, then I need to skip it. Goal is smaller than the term. Else, if the goal is equal to the term, then this counts as an answer. If I were to subtract this term from the goal, so answer plus equals the count that times this occurs. Else, I need to have the next goals. Next goals be a default dictionary of integers. So the next goals will be this goal minus whatever term this is, plus equals the count of things here. And next goals, if I don't do that, if I don't subtract out the term, then it's my next goal plus equals this count. Okay, I think that might be it. I guess I could also, this goal, no, I guess this also needs to go here as well. Next goals of this goal is equal to this count, plus equals this count. I guess I can factor that out then. Yeah, I can factor that out. No, I can't. Yeah, I can factor it out. Yeah. So it's always possible to keep the same goal as before. And skip subtracting out this term. Okay. Guess maybe return answer. Oh, I need to do mod here. And also default is spelled with a T there. Answer plus equals. Answer equals answer plus count mod. And maybe here as well. Where do I need to put this mod to make it? Maybe here. Oh, I need to also assign the next goals to become goal at the end of the thing. Maybe that works. Might need to use mod on this. Oh, great. Okay. Neither works. Answer. Okay, so index goes Huh. Okay. Let's go and print here. And let's go do print post loop the answer and the next goals. Okay. This is an unusual value for the term. Terms at index. I thought that'd be 9 at this point. Did I misspell something? Terms. And index in the range that leave the terms. So that should be 3. What is going on here? No, I mean that's right. No. No. No, I'm printing the wrong thing. I'm printing terms. Okay, this probably should be. Okay. Okay, so the term is 9. The goal currently should be 10. So 10, 1. If 10 is less than 9, okay, I think this is wrong. Let me think if the term is bigger than the goal. No, this is false. So this right. And it's not equal. So yeah, okay. So the next round you have a goal of 10 if you skip the 9, or you have a goal of 1 if you subtract the 9. Okay, that's fine. Next round the term is 4. And you can skip subtracting the 4 from the 10, so it'd be 10, 1, or you can subtract. Oh, I see. This 1, 1 needs to keep. So even if the goal is less than the term, it still needs to keep it. I guess it always needs to keep it. So yeah, this always needs to keep. So something like that right there. Oh, this also should be plus equals. What am I doing? No, what am I doing? I already did the plus right here. Okay. Okay, so that actually works now. I think there's definitely something I can improve here, but I'll wait to see if this actually, how poorly this performs before I change it. Alright, performs averagely, by which I mean there's a lot of inefficient stuff worse than this, but it's probably not good enough. So I think what I can do here is, let me just try to see how does it fare if I don't reverse it. So if I don't reverse it, then I'm going from smallest to largest. Smallest to largest. In which case, if the goal is less than the term, and my terms are only getting bigger, I think I could probably break at that point rather than continue. I can break completely, return the answer maybe? No. because there might be other goals that are smaller than the set. But there won't be later, but I won't need to put that goal in the next goals, I guess. Yeah, I don't need to put the goal in the next goal. So I think if the goal is, so if I put this here, if ever I see a goal that is bigger than the term, where the term is only going to get bigger, or goal is smaller than term, where the terms are only getting bigger, then I don't need to include that in the next set of goals. I think this works. It might lower the number of goals each time. Oh, fuck. Okay. That's pretty much the same. Pretty much the same speed. Worse speed. Oh my god. Like considerably worse speed. Okay. Okay. Hmm. Do 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 do. Go back to the other way. I guess I go back. Do 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 do. I wonder if I can optimize them where I put the modulos. Next goals at this goal. Pretty sure I want a default dictionary, so that's like easy. Actually, maybe I just want an array. Maybe I just want an array. Yeah, I think I might be overcomplicating it with the default dictionary because they have a value of n that's capped at 300, so the array could be capped at 300. Yeah, okay. I think this is probably just going to be like 0 times n plus 1 maybe. Yeah. Goals at n is pretty much 1. I don't have to keep track of the next goals, I just need to make sure I don't screw up counts as I move down. Maybe I have a set of goals that I'm using each iteration. Set of goals. So I start with n. I don't want to go through all the values. Just want to go through the ones that I need to. N can be 300, and then you subtract 1. So n is now 300 and 299. I mean, how much slower would it be? Probably a lot slower. So I have a set of n, which are my values of goals. So it's not actually goals anymore. The goals would be the index. So these would be the counts. So the number of ways of having starting with n is 1. And then for every goal index that is valid, for every goal index that's valid, do I need to order? It needs to be downwards. Every goal index that's valid. So let's say the goal indices were like 300 and 200. And now I'm dealing with a term that's 80. Then I would take the counts at 300 and add it to the count that is at 300 minus 80. I need to do this in a way that doesn't cascade the effect. So like I can't do it so that like if there was another, if the goal values were originally 300 and 220, I can't just like modify the 220 and then redo the 220 to 140. Okay, so kind of need to go through the goal values from smallest to largest. Then that would require sorting. That's awkward. Or I could go through, this is why the default dictionary is easier. So every goal value. I could go through the goal value in order, skipping the counts that are 0. I guess that caps to like 300. Is that faster? Maybe. So go from 0. So I can maybe start with counts. Okay. Every index term. Every spot that is from term to onwards for k for goal in range of term value onwards up to n, maybe n plus 1. If the counts of this goal is 0, then skip it. otherwise count of the goal minus the term plus equals counts goal minus term plus the counts at this spot. Mod so go up the ladder. There's a spot that actually has a way to get to that spot. Keep that value where it is, and also increment the number of ways of getting the goal minus this term. Okay. And then just when you hit 0, I wonder if that works. It's probably going to give me area. Probably give me some error again. Okay. Okay. I guess that works. Guess that was what they were looking for, or something similar. Okay. You have your mod constant, terms that are possible, space and value, add it to create the array, and create all terms base to some power x, and the sum to n. So that's this first part. I need this. I think this is probably better. Oh, well, I guess I could double check here if this is better. I guess it is better to reverse. Oh yeah, that's the difference. Just to improve efficiency of branching search. Just the bigger numbers just eliminate more of the possibility tree than the smaller numbers of your branch factors. It is smaller if you use bigger numbers to kind of remove from n. Okay. This is array of counts for goal values. Actually, only one way to get to one way for goal value of n, but more ways will be added for lower values depending on what is subtracted. What terms are subtracted. So you have your counts array, 0, and the nth value is going to be one way. I guess I don't need this answer. Answer eventually is the counts of ways to get to 0 as your goal. For every index and the length of terms. Yeah, terms. Okay, can iterate over terms here rather than the index. So for every term in terms, the goal is the index in the counts array, and it can't be smaller than self, or it can't be smaller than term. So like if the term is 100, then the goal needs to be at least 100 in order to have the possibility of getting to 0. Can't subtract from a term that's bigger than the goal. If the goal is 50 and the term's 100, then there's no way that you're gonna worry about that. So for every goal in my counts array, the count of that goal, if it's 0, there's no way of getting there, there's no way of getting there, so just skip it. Otherwise, increment count of goal minus term. How does it count? Okay. Did it change anything here? Just made this a for each loop rather than a index loop. Okay. So summary, this is going to be, what type of algorithm is this? It's not backtracking. Is this considered dynamic programming? Is this kind of for every term, for every goal? I'm not sure. Sure if this is considered dynamic programming, but I'm going to describe it otherwise. Keep track of, so first step is to create an array of terms that could be used to sum to n, basically powers, where base to the power of x is a term as long as it is smaller than, is less than or equal to, and from there consider basically having a way of tracking goal / count pairs, or count of ways pair, either using a default dictionary like I initially used, or array of count goal, array of counts of the goal, or array where array of goal equals the count. Use a for loop to iterate over each term, where each term will, for each possible goal, increment the goal minus term count by the goal count. So for example, let's say the goal is, let's say goals are, goal count values are, there's 101 ways to get that, and maybe 50, and there's 2 ways to get there, and the term is 25. Actually, the term is 50. So that means that you could now get to new goal count would be 101 if you didn't subtract the 50, 53 if you did subtract the 50 from the 100 and kept the 50 at the 2, and maybe 0, 2 if you subtracted 50 from 50. So there's 2 ways to get to the answer 0. So now iterate over those. At the end, return the count for goal value of 0. So however number of ways you get to 0 from this decrementing stuff is your answer. Also incorporate the mod and stuff during incrementing accounts. And be careful about not kind of double dipping at any round. So for instance, if I can't just do 100 minus 50 and make that, there's 3 ways to get to 50, and then say that there's now 50 minus 50 and there's 3 ways to get to 2 or get to 0. Just have to just worry about that correctly. I think I avoided that because I went from goal values that were smaller to larger, so that when I did the increment, I'm always dealing with something that I'd already previously passed over. So the counts can't have weird side effects there. Time complexity, this can be O of what is time complexity here? So number terms could, yeah, I guess this is O of n x. No, what am I thinking? N squared. The number of terms. The number of terms would be log base x of n, log base x of n, log base 1. What is log base 1? That can't be a thing. Because 1 to some power just can't equal something bigger than 1. Log base. It has to be n is the number of the inner loop is n. The number of terms. So it's log base 1 of like 5. That's impossible, right? Yes, undefined. If you have power of 1, but if you have log base 2 of 5, that's roughly, So in theory, this would be log base x of n, where n is the n is the goal value, and x is the power. So in the worst case, where x equals 1, where x is the power x greater than 1, in the worst case where x equals 1, it is going to be O of n squared. Because the number of terms you get, I think, correspond to your biggest power. So if you're dealing with squares, and let's say that n is 100, then the number of terms would be like 1 through 10. 1 squared, 2 squared, 3 squared, all the way to 10 squared. 10 squared would mean that you're dealing with the root, the nth root of the nth, no, the xth root of n. Oh, wait, you're dealing with the x root of n, not the logarithm. Actually, yeah, oops. Okay, it's not log of x, it's n times, n times n to the power of 1 over x, or the x root of n. So if you do n to the first times n to the 1 over x, then that ends up being n to the power of 1 plus 1 over x. Wow. It's really getting to the weeds. I guess so n times n to the power of 1 over x, which, yeah, I guess it's not logarithms, there's a number of terms there, which equivalently is O of n to the 1 plus 1 over x is x plus 1 over x. There's a slight order of operations incorrectness there, but I think people might understand, hopefully. This is because the inner loop iterates over n, and the outer loop iterates over the number of terms, which is proportional to the x root of n, which is same as n to the power of 1 over x. Space complexity, this is going to be O of n, yeah, O of n with the counts array.